Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh, ladies and gentlemen. Welcome back to another live stream. Alright, so we're back with some Vulkan and Rust. A lot of you have requested some follow-up videos on the previous video that I've done a long time ago about Rust and Vulkan tutorial kind of thing. So we're coming back to it. To be clear, I haven't programmed using Rust and Vulkan for a very long time now, but let's just go and try it out. So, of course, I'm going to be using Rust Rover. I have JetBrains, IDEs, and so yeah. Local4Games, welcome to the live stream. And oh, I just forgot to actually even copy the video URL to two announcements. Please make sure to join my live stream. There you go. Okay. Sorry, to join my Discord server so you can get notified of new live streams, and then you can also vote. So yeah, pretty much. Okay, so love you, bro. Got notifications on. Nice, thank you so much. Okay, Local4Games, welcome to live stream. Let's go. Okay, I think let's start already. I've never used Rust Rover, so we're just gonna try it out in this live stream, and let's see how far we could go with this. So yeah, new projects, Rust, and I guess let's call this location in tile, tool chain location. Okay, let's call this, I guess, Kodotaku Vulcan Triangle. Maybe, I don't know, or honestly, let's just call it Vulcan. You never know. So binary application, yeah, create, and let's see how it goes. If there's any suggestions or questions, let me know. Microsoft Defender, blah 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 blah. No. Yes, don't show again. And let's see how good is this IDE too. Okay. Alright, lovely. So let's actually go to this right now, and I need to do some things that I like to do. Actions on save, make sure reformat code, optimize imports, rearrange code, run code cleanup. The other one that I also like is ligatures, enable ligatures. So you get stuff like this. What else do I like? I don't know. So yeah, this should be. Oh yeah, I forgot about the mouse wheel thing. Let's go ahead real quick. Wheel. There you go. So I could use my control and mouse wheel to actually zoom in and out. I never understood why that's not the default, but anyway, who cares? So right now it's updating creates index. Nice. So we're gonna be using, of course, the binding that I used before, which is Ash, which is pretty much the best Vulkan binding, low-level Vulkan binding. It's of course unsafe. So Rust, Ash. Let's see. Long time haven't used it, but let's go. GG, sleep, however, watch the stream when I wake up. See you, man. Thank you so much for tuning in. See you later. Good night. Okay. Oh my god, my first video is right here. There you go. It's like in the search. Amazing. Okay. All right, so we're back into it. Cargo add ash. Okay. So let's see how I could add that. Let's go to cargo toml, dependencies, and I guess how do you add? Okay, ash equal to, and it doesn't give me the version for some reason. Anyway, let's just click here. There you go. What is the latest version right now? It's not really saying, which is quite weird. Oh yeah, you just, I guess, copy. There you go. Okay, you just copy that, and there you go. Okay, so we need this. We also need some, we need winit, I think. Yeah, we also need winit. Let's go to grids.io documentation. Let's go and copy this guy. And there you go. We got winit on. Nice. And what else? What else? There's also some other module that I remember which is, I think it was Vulkan or something. Actually, hold on. Let's go to the GitHub repo. Pretty quick. Come on. And their cargo features, no. Okay, maybe it's in the tags or something like that. No, it's not. Okay. So Ash Winnet, yeah, it's basically Ash window. Yeah, exactly. That's basically it. Let's go. And let's actually see how we could copy this around. Let's go. Copy, I guess. Oh well, that's not what I expected. Okay, let's just copy this instead. And there you go. We added Ash window. Okay, what's else now? Yeah, I think that which basically would like it's like a glue between Winnet and Ash essentially. But yeah, I think that's pretty much it. There's also some other one which is called any error or something like that. I don't really. Anyhow, I think yeah. Anyhow, Rust. There you go. This would also make it much easier with the error handling. So let's go ahead and do this. And yeah, that should be it pretty much. That should be it. Salim, welcome to the live stream. Going back to what is hard to adjust to. There are so many keywords and syntax compared to CL. Oh yeah, that's for sure. Okay, so let's see where we can start here. I think I remember, but let's see if I can. I don't even know if like some we'll see how it goes. Uh, okay, gotcha. Come on. Okay, entry and Lloyd, I guess. Yeah. There you go. Pretty nice. Okay. Entry Lloyd. And of course, this is in safe, right? Or isn't it? Surrounded in safe block. Okay, that's nice. What's going on here? Call to an unsafe function. Who cares? Okay. So here it's going to be like an anyhow error, I think. Oh, it's not Zig. Okay. It's going to be a result or anyhow result. Yeah, anyhow result. I think. Bruh, come on. Help me out here. Oh, yeah. My bad. Okay. Coming back from Zig. He's messing up with me here. But anyways. Okay, so it should be void, which is basically a unit like this in Rust, right? There you go. Cool. So we got an entry, which basically would go ahead and load the Vulkan library. Okay, next up is, well, actually, let's see first of all if this actually works. And in fact, let's say, okay, yeah, and then just nothing. Okay, let's try to debug this and see if this even works real quick, just so I don't get any surprises. Okay. Version requirement for dependency Ash. Okay, cool. So at this point, it should basically have gone ahead and loaded the Vulkan dynamic library, essentially. Yep, pretty much. Now let's go ahead and try to create the instance. Instance is equal to entry dot create instance. Let's go. And then it needs the instance create info. The instance create info. Okay. And well, there you go. And let's grab the builder. And let's use the builder for that. And yeah. And of course, you need to pass in the address of the instance create info. What else? What's going on here? Surrounding safe block. And yeah, I think that's news results that must be used. Where is that exactly? Oh, I see. Okay. What's going on here? This function takes two parameters. Oh, takes two parameters? What? Are you kidding me right now? Fill missing arguments? Oh, allocation callbacks. I forgot about that. Okay, cool. So, and then basically this would give us the result, and then we're just going to unwrap that out, which is nice. Okay. Now we got an instance, a Vulkan instance, though we could indeed give it some more information, which we actually need to do. We need to grab the instant extensions and what else? Enable layer counts. Like the S-type stuff would be handled for us by Ash. So that's nice, at least with the builder. You don't have to do that. There's the AP application info, which you can use to actually use some sort of Vulkan version or whatever. But what's really needed right now is the extensions. So let's see how we can actually get the extensions using Winit. And in fact, let's first of all get Winit working, in fact. And how you do that, well, it's called, I think, intrigger. Hold on. Winit, event loop. I bet. Okay. Event loop is equal to event loop. Okay, great. New. And there you go. We got one event loop right there. Let's also create the window real quick. Sup, hello Ridwan Karti. Welcome back to the live stream. How is it going? Yeah, pretty good so far. I'm basically trying a new IDE, and I haven't programmed in Rust and Vulkan for quite some long time right now, so everything is going well so far. Okay, so Winit window. I guess let's maybe go with a window builder, maybe. It's not totally new stuff, but yeah. Window. Well, compared to YouTube in general, yeah, it is new stuff. Okay, let's see. Window. How do you even create a window? I forgot. Let's see. Create window or something? No. Maybe it's window. Bruh. Okay, new. Oh yeah, and then you give it the event loop, an address of the event loop, of course. And let's just unwrap that. Good luck. Thank you so much. Okay. So right now, I think we got a window. Let's make the event loop. So window dot run. Well, not event loop dot run. Oopsies. And then if I remember well, yeah, there you go. You have, I think you have to do move here. And I don't remember the signature of this. Let's see. It's gotta be okay, can I see the documentation of this? There you go. So it's gotta be event loop window target, and control flow. Okay, event. What is the other one? Is event loop window target, or window target essentially. And what else? We also have control flow, as I said. And yeah, that's pretty much it for that one. And this is basically unreachable, so it's not even needed, really. I don't know if I can already tell it that it's unreachable. It seems like it wasn't. I think it wasn't a feature before. But here you go. By the way, if you can't get the required extensions, you could just hard code them to vkh our service. We can actually do that using Ash window, which is quite lovely. So let's see how I could do that actually. That was the one that I was about to do. K-hash window, and then you enumerate required extensions, and then you basically give it the raw display handle, which you could actually get from, if I remember well, from the event loop or from the window. Yeah, but I do remember that you had to import like some sort of trait or something like that to allow for that. Okay, let's see how we could do that. Okay. Winit window. Let's see. What is the crate is called again? Oh, sorry, Ash window. Let's have a look real quick. Window handle interrupt for Ash. Why this is... Nah, this is not the one. Okay, let's see this one. And let's see the repository. There you go. And let's see what we need here real quick. Rust moment import the straight you get the required extensions. API with no utility libraries. Bruh, come on, let's see some example real quick. Ash window. No, not this one. Examples. And src. Lib maybe. And it should be somewhere here. Yeah, there you go, I think. Raw. Oh yeah, I just forgot. Raw window handle. I also need that. So let's actually import that too. Copy this guy, go back to cargo toml and do this. And there you go. Let's reload that. And with that out of the way, yeah, I just gotta basically import these traits, I think. Has window handle and has display handle. So let's import these to get our functions. So use raw window handle has display handle is what I need here. And hopefully I could get it from the window right now. So let extensions or required extensions window dot display handle or something. Bruh. Okay, let's see what is it called. Display handle seems like. Yeah. Extensions. Okay, window.display handle. All right, it didn't give me that, but yeah, there you go. It works. Interesting. Can I use cargo check instead? Hold on a second. Maybe that would make my experience better with that. Okay, lovely. Okay, what is happening here? IDE internal error occurred. Let's go. All right. Maybe I should just restart this guy just to make sure the IDE is not messing with me. I mean, it's still not released yet, so that's something. Rust rover. Bonk. Okay, let's see. So this raw window handle is basically like a glue between the windowing libraries and whatever other API stuff. But anyways, let's see what we have here in the current scope. Okay, what if I done, oops, come on, dot, come on, no way, hold on. Let's see the display handle here. Yeah, the raw display handle. Yeah, I forgot about that completely. Raw display handle like this. Right, it is like that. Now let's see what it's saying. No method named found for struct. Oh, Hold on a second. So the IDE have removed that automatically, the trait that I actually imported. So that's why my, oh well, anyway. Ash window, and let's import, well, it's not Ash window. Raw window handle has display handle, and now it should work out. Let's go. So my IDE apparently have removed the import because it was in use at that point when I saved. No method. Oh my god, come on, bruh. Really? Yeah, why it removes it? This is stupid. I mean, hold on. Let me actually remove that. Come on, really? I mean, I'm using it right now. But anyways, let's go to save actions. Let's remove that thing. Optimize imports, I think, is what's making problems here. Okay. Raw window handle now. It has display handle. And don't mess with me again. In used import. It's still in used? What? Okay, let me remove this and let's just run this and it would give us a more meaningful error, I think. Oh, the type is experimental. Interesting. Interesting. Yeah, I thought it wasn't in feature yet, but yeah, seems like not yet. All right, so method not found is available for window here. There you go. It's telling me what to do, which is exactly what I think I've done. Yeah. Method cannot be called on window due to unsatisfied trait bounds. Interesting. Okay, what if I called it an event loop real quick? Well. Found trait bounds were not satisfied. Oh, what? Is deprecated? Interesting. Okay, they somehow deprecated it. But how am I supposed to use it then? You need the other traits, I guess. Uh, Let me remove this. No, it's deprecated. It's deprecated for some reason. Display, use raw, use has display handle instead. Okay, let's use has display handle instead, maybe. And let's see what to do there. Bruh, this is not helping. Chat GPT for the win. It's basically display. Yeah, it's just display handle right now. It seems like that got changed. So yeah, display handle. It's as simple as that now, I think. Method not found in event loop. Interesting. Okay. Well, what about the window then? Not found. This is crazy. Display the access wrapper. Yeah, this seems like it got changed somehow. Get a handle to the display controller of the window in system. It's literally display handle, so what? Really? Okay, let me see the examples. It's still using raw display handle, like bruh. And it's deprecated, but they're still using them in their own official examples. Interesting. Oh, well, maybe try grabbing the imports from the example. It's not. The example is using the deprecated thing, first of all. That's the thing. But it's pretty much what the example is doing is raw display handle. And it's just using the other guy, which is like raw display handle, I think, or something. What was it again? Hold on. Let me do this. It's using this. Raw display handle exists for struct window, but straight bounds are not satisfied. Interesting. Okay, let's go back to the example. I think I'm probably missing something. And let me remove this. There's no need for this. Okay. So let's go back. Let's see, code, and let's go to examples. Real quick, let's go to, I guess, SRC. Is it? Okay. Or in fact, let's look for the toml. Let's see the toml, how it is. Maybe I'm missing something there. Raw window handle, and we got the winit, and we got the ash, and we got the ash window. So what's up with that? Ash window. Weird. Expected. Oh, well. It seems like maybe this is working, although it's deprecated. But type mismatch. Expected raw display handle, but found raw display handle. What? Expected raw display handle, but found raw display handle, but it's still type mismatch. How in the world? No idea. Yeah, something is fishy here. They have changed something about it, I guess. Let's see. Vacant results. That is amazing. Well, display that wraps around the raw display handle. Oh well. Okay, let's go back to their example and see if it's really been in triangle RS. Or let's go to lib.rs, okay? And let's see where they're doing that. Raw display handle. Okay. That's exactly what I'm doing, I think. Yeah. And what they're importing has raw display handle, has raw window handle. That's exactly what I'm doing. Something is wrong with it. Okay, I guess let's use some other version. Pretty much. I mean, what you gotta do. Let's use some other version, I think. So we have winit, we have ash window. Okay, raw window handle. What if we use like some old ash window version, maybe? Okay, let's try that out. Let's see what's gonna happen. Gotta go sleep. See you next time. Goodbye, everyone. Goodbye. Thank you for tuning in. Have a good stream. Thank you. Okay, let's see what we have again. Method cannot be called on window due to intest. This is stupid, like ash window. Well, this is ridiculous. It is important, but it's telling me that it's not important. Go ahead and import it. What? And, yeah, there you go. It's like, what? It's exactly the same exact thing, but it's not working out. Amazing. Okay. Okay, let's use this instead now. And let's see. And how's display handle? Display handle. Method not found in event loop. I think when it doesn't support that yet. Maybe. Okay, let me see here. Well, winit. Let's go to winit GitHub. Okay, create display handle. Event loop 3 changes. There is some changes there. Okay, wait a lane. There doesn't seem to be anything here. Okay, let's go to the other guy here. Not Ash, but the other one. The I guess the row window handle is what making us problems here, right? Or is it? Yeah, I think so. Has display handle. Display the X around the display handle. Like WGPU and gluten. Yeah, this seems to be got changed and it's messing up with everything else, which is crazy. Okay. Update to new raw window handle strategy. Interesting. Let's see. 2 weeks ago. Interesting. So this change was just 2 weeks ago. Well, damn it. Okay, essentially a combination of explicit support through the, which is enabled by default, also adds optional support for. It also adds a lifetime to window attributes. Thanks for following up on this. Approved here, 12 commits. Okay. Proving the honor changes. So I think, well, we could maybe do something else because this just doesn't seem to be working at all because of the new changes. Maybe the winit crates haven't been updated yet. It does seem like you have fixed it, but maybe not. The update is not published yet, maybe. Either way, I think let's just try to do something pretty safe, I guess. Raw window handle. Let's maybe use 0.5.0 for that version, and let's see if we could, if that would help. But yeah. So yeah, we would have not wasted any time if it wasn't for those stupid changes. But well, what you gotta do. And import. Come on. The operator cannot be applied to type. Oh yeah, this is not a result. Okay. All right. So as you can see, this actually works out with 0.5. What was basically slowing us down is just all those new stupid changes, which I have no idea why they even done that. Which just made me like, I don't know how much time we have spent on this for no reason. It's like it's around 30 minutes already, which is stupid. Anyways, I'm gonna be back just in a second. Hold on a second. All right, back. Okay, let's just get back into this. So right now we have solved that by just basically, uh, degrading to the 0.5 version because 0.6 version just doesn't work for whatever reason. Variable extensions is never used. Okay, pretty cool. So now we could just enable extension names and add extensions there. Okay. No method named for structuring the current scope. Huh? Enabled extent. There you go. Enabled extension names, and let's just give it these required extensions essentially. This is the required extensions pretty much, and yeah, that's pretty much it, I think. What is okay, cool. Now what's next? What's going on here? These are just in used. Okay, lovely. So now let's actually match on events, I think. Okay. And then let's just match on I guess when it's event maybe. Yeah, and let's match on, let's see. There is window event. There is also redraw, main events cleared, loop destroyed. Okay, cool. What about window events? Cool. All right. So it would give us the window ID and the event. Seems like. All right. Can I just do something like this? Oops. Then something like that, and non-exhaustive patterns. So just do this. And yeah, now we're just gonna match on that event essentially. Oopsies, and we got all this craziness. Okay, cool. Well, let's just go with window event closed. Close requested. And at that point, I would just say control flow dot set exit. Basically, that should do the trick. That should basically quit when you close the window. And add a pattern like that. And yeah, and for this one, it's going to be in use, so who cares? And that's pretty much it. Let's run this out. And there you go. We got a winit window, which we can close. And in fact, we're passing the right extensions right there, which is nice. Now, I'm going to be using the latest Vulkan version because why not? But for compatibility, you would like to maybe use an older version. But basically to do that, what you gotta also do is essentially go to info, p application info, and just pass in an application info. I guess let's gotta go with the builder maybe. Builder dot, and yeah, and you could just pass in the API version. You could pass in other stuff, but that's all the only things that are passing basically. So for that, we're gonna say, yeah, VK API version 1.3, and I'm not sure why it's not like breaking this line down with the auto format thing, but for some reason it's not. Let me see. Hold on. Settings. Oh yeah, we're already here. Cool. Yeah, for some reason it just doesn't. But anyways, let's just break it ourselves down. Okay, that's much better, I guess. Okay, nice. So now we got pretty much the instance down. Next up, we'd probably want to create the surface, which we're going to use here winit ash window. To do that, create surface, and then we got to pass in a reference to the entry, a reference to the instance, and a reference, well, a display handle. Well, for the display handle, we're gonna go with, yeah, we're gonna go with event, or let's just go with window, because why not? Raw display handle, just like we've done before, and then the raw window handle here. And finally, the allocation callback, which is always gonna be none. And yeah. Okay, what's happening here now? It's maybe in safe, yeah, it's arrived within safe block. And that's pretty much it. Now we got a surface for our window. Okay, what's next? Let's create a device, I think. In fact, let's get a physical device first, and that's pretty simple. I'm just gonna take the first physical device basically, and how we're gonna do that? Well, instance dot enumerate physical devices. Let's go. And I guess I'm just gonna take the into iter. Basically, I'm consuming the iterator or the vector basically, and I'm just gonna take the first element. And how do you do that? You could just say next, basically. And yeah, then you could just say like, So here we have an option. We don't have a result. So what we could do essentially is, let me try to remember this, how I was doing it. I think it was like anyhow. Okay, hold on. Let me go to the anyhow crate real quick. And let's see. With context, right? I forgot about that completely. With context, and then you basically just give it some context, if I remember. How do you do it? You basically make a closure, and then you give it the message, I think. And for that, we're gonna do it like this, and we're just gonna pass in the. Actually, we could probably just say the context. Yeah, we don't not even have to do this. We could just say context. Okay, cool. But if you're doing like some heavy calculation, for example, here they're using format, which would probably allocate memory and stuff. So you'd better go with the closure one because it's lazily evaluated, while the context function is not lazily evaluated. But anyway, it doesn't matter for me here. No physical device. This shouldn't really happen, honestly, but you never know. I'm just having it here anyways. And yeah, so with context or dot context, what you do basically, you turn an option into an actual result. So I could basically propagate it back, which is quite lovely. And somehow I still get a picture of physical devices. That's weird. What? How? I don't think that's the case though. What? How? I used next, dot next function into iterator, dot next. Weird. Okay. Can you just print that, please? Because this doesn't make any stupid sense. Okay, and I think you just do it like this, right? And that's pretty much it. Let's see. Cannot be formatted with default format. Yeah, it's a vector for some reason. I'm very confused right now. So what is this then? Enumerate physical devices. Oh, I see what's happening here now. Yeah, I see. Because this is like a result of Victor. Result Victor. So I gotta first of all enwrap the results and then do that stuff that I wanted to do. Okay, so right now we actually got the physical device. Next up, we could probably create a device. And how do you do that? Well, I think you do instance create device. There you go. And then basically passing the physical device that you have chosen. Don't go crazy with this. Just choose the first physical device. Pretty much. That's nearly always the good option to do. Anyways, provide the arguments. So it's gonna need the device creates info and the allocation callbacks. Okay. Vacay device creates info. Let's go and builder dot. Okay, so there's some things that we could do here, but pretty much the most important one is the queue create infos. Right. And of course, there's gonna be a reference, by the way. There you go. And then, of course, none for the allocation callbacks, I think. Okay, cool. This is also, I guess, in safe, maybe. But yeah. So right now, let's just create a queue, create info, I think. And how are we gonna deal with that? Well, vacay queue create info, device queue create info, right? And we're gonna go with the builder. We're gonna go with the queue family index. Okay, 0. I mean, you can indeed go ahead and call some functions, to get more information on which family index you want to use, etc., and if it's supported and stuff like that. But there's really no need. Most of the time, the first key family index supports everything, like supports graphics, supports compute, etc. But pretty much you can see that I'm not really going anything that is not really necessarily required, I'm not doing, while some other tutorial would actually do. But anyways, like Vulkan is just super complex and crazy enough. So yeah, key family index. Okay, what else now? What else we need? I think we also need the queue priorities. PQ priorities. Yeah, queue priorities. Let's go ahead and basically do. I don't know if Rust actually supports that, but I do remember like maybe it's like slice and from ref. Yeah, I think from ref or something. I don't remember exactly how you actually do it. I think that's maybe it, I guess. Yeah, it does seem so, which is nice. So that's pretty much all I really need. I need the key family index and the key priorities, which here I'm just passing one number. It could be 0, it could be 1, doesn't really matter, honestly. Okay, what else? At least in this case, since we have one queue family thing and one queue basically. Anyways, so calling and say functions around that guy. And yeah, I think this should probably be it. Now, to actually see and make sure everything is going right, what I'm going to do, I'm going to use like you need to install the Vulkan SDK, and then you pretty much get a Vulkan configurator, which you could use to debug your Vulkan applications. So I'm gonna make it on API dump, and let's see. And there you go. And let's see, and as you can see, why it's doing all this stuff, weird. VK create device, as you can see, that have succeeded. So pretty much we have created a Vulkan device at this point, which is pretty cool. So yeah, let's make sure that the validation is okay. Q create info count must be greater than 0. Interesting. Q create info count. Okay, Q create. Oh yeah, I forgot to actually pass this up. I need to pass this guy here. So basically do this, I guess. And in fact, let's just use the same kind of thing. Slice from ref. And then this. And there you go. I find this very annoying that it doesn't like go down the line. Why choose Ash instead of Volcano? Now, it depends on your goals pretty much if you want a higher level API or not, and the safe API or not. But honestly, myself, like, I kind of got used to the raw Vulkan API. And so right now going to something like Volcano, I'd have to actually learn how the API of Volcano is. And it contains a lot of namespaces and stuff. So that's what, I don't know. It's like I just don't want to use it myself. At least not for this project. I'd like to just use Ash pretty much for my own goals. But it depends again. It depends on your own project on which one you would use. But you know, myself, I choose Ash for this particular purpose. Okay. Surface physical device. But if you want, you know, an easier route, you probably want to use Volcano instead of raw Ash. It's also much safer, and yeah, and it also helps you with a lot of things. All right, that's pretty much it. Hopefully that answered your question. Okay, now we got the device down. What's next? Well, maybe we'd like to get a GPU allocator already. Maybe. Maybe not. Okay, well, yeah, let's just start small and let's just, I think, go without an allocator. Or, I mean, let's see. I don't know. GPU allocator, Vulkan, Rust. I mean, I used one before in my previous video, which is this one, which worked just fine. This would basically helps us with, you know, Vulkan allocations and Vulkan buffers and stuff like that. And as you can see, just requires instance device, physical device, and stuff like that. Yeah, so let's add that, I think. Why not, I guess. Okay, cool. And by the way, welcome to the live stream, Naji, BD, welcome, welcome. Okay, so that's pretty much it for that one, window-rs and WinAPI. Okay, let's create an allocator basically. We added that crate already. So it's still loading. And it should set us up for create buffers, buffers and stuff like that. Although to be clear, I don't care about compatibility. Like if you're using Mac OS and you want to support other platforms like Apple products in general and stuff like that, you'd probably want to go with one like version 1.2, because that's what's currently supported right now. If you want even more compatibility, you'd go with 1.1. If you want maximum portability, you would go with 1.0, basically the first version, but I don't really care. It gets really crazy when you care about portability and stuff like that. But anyways, I'd really not recommend doing that as a beginner. It's like you're just gonna go crazy with trying to make this work on all platforms in the long run, you know. So yeah, that's pretty much that's just something. Okay, like advice basically. So all right, so what's we gotta do right now? So as you can see, it also supports DirectX 12, this allocator. I'm just gonna go with Vulkan. Okay, lovely. And this allocator right here, I'm gonna go with Vulkan again. And there you go, mutable allocator. Okay, cool. So right now I pretty much got the allocator. So we got the instance, we got device, physical device, debug settings, default. I'm not sure what debug settings are possible here, but you could check that out. There you go. You could log memory information, leaks, etc., etc. Pretty cool. And then there's this buffer device address, which is true. Ideally, check the buffer device address features struct. Buffer device address. Now, I'd very much like to actually use this because I won't have to deal with descriptor sets and stuff like that, which is just so stupid. But honestly, yeah, see, it's gonna be crazy. But for now, you know what? Let's just embed the vertices into the shader, and then later on we could look into the sub. But anyway, we have the setup for that. Okay, I think let's just probably go. Oh yeah, we want the swap chain. I almost forgot about that. Okay. Right. Let's see how we can do that. Okay. Let swap chain is equal to. Well, in fact, I think we gotta load that first somehow. I remember. So okay. Right. Create swap chain. Yeah, you gotta load the extension somehow. I don't remember exactly how. Vacay. What else there is? There's Ash too. Thanks, man. I really like this kind of streams. You're welcome. Ash. Do you use like Rust? Ash. Where is it? Yeah, I think Ash extensions maybe. Yeah, there you go. KHR. Swap chain. New. Yeah. You give it the instance. You give it the device. Now, what it's going to basically do here is we'll basically go ahead and load the function pointers from the library for the swap chain extension, basically, when you do this. Now, you got to make sure that the swap chain extension exists before trying to load this first, basically. But anyway, I don't really care. We're just gonna go with it. And of course, before we can do that, we have to we have to enable the extension. And this is like a device extension, so let's actually enable it. I don't think I did yet. Yeah, we didn't. So let's go ahead and enable the extension. So enable extension names. All right, now this actually requires an address to a slice of conc char. Cool. We only have one extension currently, so we could maybe use that std slice from ref thing. And then now we just need a conc char, which is basically a C string, basically. Let's see. Now I pretty much, this is very annoying that it doesn't go to the next line automatically. It should. but it apparently this IDE doesn't, which is very annoying. So let me try to improve this a bit here. Okay. Oh, hold on. Can I check this guy? Cargo check. Run external linter. Rust FM. Oh, there you go. Use Rust FMT instead of the built-in formatter. Run Rust FMT automatically on safe. Hopefully this would solve the problem. There you go. Let's go. Right now we're using Rust formatter. That's much better. Oh my god. Let's go. Don't use the built-in formatter. Use the Rust FMT one. There you go. So, okay. So from ref what? From ref? Does using Rust with this and safe bindings really help? What do you mean exactly? Does using this with this and safe bindings really help? You know why it's in safe? All of these functions are in safe pretty much. The main reason is the fact that, well, like, I mean, if you check on each function why it's in safe, you can know why. For example, this Lloyd function, here's why it's in safe. DL opening native libraries is inherently unsafe. The safety guidelines for library new and library get apply here. No Vulkan functions loaded directly or indirectly from this entry may be called after it is dropped. Basically, it's unsafe because, well, it's loading a dynamic library from the operating system, which is the Vulkan SO or Vulkan DLL, basically. And it's loading functions from it. Now, using those functions after this entry have been dropped in any way or shape or form is unsafe. So like you could basically leak them essentially, and they really cannot do anything. Like Rust basically protects you from memory leaks, not too much such things like implicit stuff. But anyways, hopefully that kind of got an idea. Enumerate physical devices, call to an unsafe function, create surface. So for example, create surface here. In order for the created vacay surface KChar to be valid for the duration of its usage, the instance this was called on must be dropped later than the resulting vacay surface KChar. Now, as you can see, this create surface function is unsafe because you gotta make sure that the instance live as much or actually, yeah, the instance live as much or longer than the surface, basically. Like, if the instance got dropped uh, before the surface, then you got a problem. This is why it's unsafe, because you got to make sure that you uphold this condition. And you could easily do that by just, creating a struct and just putting them on there. And basically, yeah, as simple as that, I think. But anyway, let's not waste a lot of time on this. Okay, so I don't really remember how do you create like C strings in Rust. But let's try to figure it out. I think FFI maybe CSTR or C string. Not sure. Maybe CSTR should be fine. Maybe from bytes until null. From bytes with null. Okay. From PTR. What do you mean by this? Hold on. Let us go to the documentation and let's see. Okay, so this creates a C string wrapper from a byte slice with exactly one null terminator. Bytes, results. If the null byte may not be at the end, from bytes until null can be used instead. From bytes with null. Okay, interesting. Oh, I see. So yeah, I think that should probably work out with null, and I basically gotta make sure to do, well, actually, hold on. I guess maybe I don't even need this. Hold on a second. Hold on. I think I got a little idea here. From ref, well, it's called hash, right? Okay, extensions and KHR, I think, yeah. Swap chain name. Oh yeah, that gives me the static CSTR of the extension, which is nice. Now what's happening here? This function takes 3 parameters. Which function exactly? No idea. Okay, hold on. Let's take it slowly here. Oops. Cancel. Okay, let's just copy this guy and let's see what we got here. Oh, in fact, it's fine. Seems like. Hold on. Swap chain name. Okay, what's happening now? Okay, expected const sharp but found CSTR. Okay, what if I passed you the pointer instead? There you go. Well, maybe. Hold on. Expected reference to a const char, but found that. Interesting. Yeah, okay. Let's see, let's swap chain name. Okay, cool. Why 2 arguments were supplied to this? There you go. This seems to be working out. Interesting. Lovely. Okay, so that's pretty much it, seems like. Swap chain name, blah, blah, blah. No. Save swap chain to dictionary. Okay, so this should hopefully work out. And how we can make sure that this actually works out is by too simply, well, hold on, what's going on here? Are incorrect. Okay. Dot new. And we basically gotta give it the instance, and we gotta give it, I believe, the device, a reference to these. What's happening? This seems to be fine, okay. And now let's just try to debug this. And let's see. Okay, nice. Let's make sure to use the API dump here, and let's see what's gonna happen. Okay, enumerate, not here. Okay, let's look for create device. There you go. So vacate success. Let's see the extensions that got passed. And there you go. The extension that got passed is vacate HR swapchain, which means it's working out. Lovely. And that's basically how you check you're passing in the right stuff. It's kind of tricky to like make sure that what is going on from Rust through the C API is correct, so this is some way to actually check. Anyways, so that's pretty much it right now. We have loaded the swap chain functions or extension essentially. Now I could use their stuff. So let's create swap chain. Now create info. Swap chain create info. Create info KHR and basically, well, how do you Yeah, builder. And then let's see what we got here. Well, why it's only passing in this type? There you go. Okay, so first of all, let's actually pass in the surface. Pretty simple. And maybe I gotta pass a reference to the surface around in save block. Must be used. Okay, well, this is actually the Swapchain extension, not really the extension itself, basically. So yeah, and I'm just gonna store it here. Let's make sure that this is working out. Yeah, seems like, I guess. Right, let's make sure to do this. By the way, you can notice that even this is a builder, I'm not actually saying .build, which I should, but I don't need it here because when you say reference, it automatically does that. It automatically builds the builder. So you do not have to do that. Except for, let's say you have like a collection or a slice of builders, then you would need to build the builders manually, basically. 'Cause you cannot really use that. This method takes two arguments, but one was supplied. Provide the arguments. Yeah, it's allocation callbacks. I always forgot about that. I always forget about that. There you go. None. Okay, what else? Variable swap chain is never used. Okay, cool. So that's the surface. What's next? There's the flags clipped. Probably true. That's just a performance kind of thing. Well, basically, if you're gonna be using the swap chains pixels, uh, like you're gonna capture it from it, the pixels, then you gotta make sure it's not clipped. But you know, otherwise just use true. I don't want to waste a lot of time here, honestly, with this. So yeah, I'm just gonna skip through a lot of things. Composite alpha. Well, vk composite alpha flags hr. I'm just gonna go with opaque. Now, as I said before, a lot of things you should check if these things are available or not. For example, for the composite alpha, let's say you gotta check if this composite alpha that you're trying to use is available or not using some other function, etc., etc. But just just skipping through that stuff so I could go as easy as possible, as and as fast as possible, basically, because that can take a lot of time to do right. But this should work pretty much for most machines, really. Just anyways, composite alpha, image array layers. This should be one. Okay, what else? Image array layers, image color space. Yeah, hold on. Okay, image color space. I'm just gonna go with, well, if you go to the, what is it called? Vulkan. I forgot what is it called. Caps viewer. Yeah, it's Vulkan Caps viewer, and apparently I don't have it in this installation. So Vulkan Caps viewer. And where can I install it real quick? There you go. Windows 64-bit. Save. Let's go. Come on. Let's go. Let's go. Okay. Let's extract all. Extract. Release. And let's just run it. And yeah, that's just how you do it. All right, lovely. Now, yeah, there is not. Okay, cool. So let's just go to, by the way, if the device is not already present in the database, you can contribute to the database by uploading your driver and GPU information, etc. So other people can actually get access to it here. It's just like a GPU database for a lot of Vulkan devices. So for example, let's say this one, this device, and then you could just see what is the driver, what is the type, name, architecture, version, properties, features, extensions of this particular device, essentially. But anyway, so this is mine. Um, let's see, Q families. What do you think about Web GPU? I, well, it really depends. It's all depends on what you want to do, really. I mean, pretty much Web GPU is just like an API too, and like, do you mean like WGPU? Like there is some implementations like WGPU, which is like a Rust implementation of it, which is pretty nice. But the thing is, this WGPU is just using like Vulkan, Metal, DirectX 12, and OpenGL, etc. And on browsers, I think it's using WebAssembly, WebGPU, WebGL2. But pretty much, like if you use this, you're pretty much using Vulkan just indirectly. Uh, but yes, have its own stuff. I just don't want to waste a lot of time on it, honestly. But it's a good choice, but it would limit you to their API. I don't think like they even support ray tracing yet. But pretty much, if you really value performance and you don't care about web, you probably wouldn't like WGPU. If you care about portability, like you want your application to or your render to work on all platforms, including web, um, then you probably want to use WGPU. So yeah, that's pretty much it, I think. Uh, but if you like want to be on the like best performance and like use the latest features available and latest technology available, then go with Vulkan or DirectX 12 or something like that. But yeah, pretty much Vulkan. Hopefully that answered your question. You can see that I'm trying to go as fast as possible with this. Okay. All right. Oh yeah, I forgot. I wanted to show you the surface. Yeah, if you go to the surface, you can see the surface formats that is available for your own thing. Now for me, I'm gonna go with sRGB. I'm gonna go with B8G8R8 A8 sRGB and non-linear KHR. Okay, so well, it's gonna be color space. Okay, color space KHR. Oh, what? Hold on. Really? Why it's not showing me anything? Oh, there you go. And it's just a little bit slow. Okay. Let's go with sRGB, non-linear for that one. And let's go with image format, I think. Or let's go with extent first, why not? I guess, or hold on, what? Image color space, image array layers, okay. Ooh, weird. Image format, okay. So vk format, I think, and let's just go with, what is it called? B8, yeah, this guy right here. I'm gonna go with this one, I think. Or we could go with this one. Basically, if you want sRGB, then you would want to go with this one. Otherwise, you would want to go with this one. So I'm just gonna go with sRGB, I think. There you go. And what's next? Let's see. Image format, color space, extent. Image format, color space, array layers, composite alpha clipped surface flags. Image, did I do image extent yet? Well, this image extent is kinda crazy. Gonna keep it as as the last one, I think. Image sharing mode. This is pretty simple. We're pretty much using only one queue, and in fact, I kind of forgot to get the queue. Pretty much the queues gets created when you create the device, but you still gotta get a handle to it. So here's how you do it, basically, I think. Yes, device.getQueue. Get device queue, and then you tell it which queue family index. Pretty much, I'm just hard coding this into one queue family because it makes everything much easier for a beginner. And then the queue index 0, which is the first queue. And yeah, surround it and save block. Okay, cool. Okay, image sharing mode. Now, since we're using one queue family and one queue even, we're just gonna go with exclusive. Hold on, what? Sharing mode, hold on. Oopsies, sharing. There you go. And let's go to exclusive. Otherwise, we would use concurrent. Okay. What else now? There's minimum image count, which I'm just gonna hard code for now as 2. What else? There's image extent. Now there's an exception to this in other platforms. Like Wayland, it would... Well, we're gonna come back to this later, okay? Alt Swapchain image, minimum image, pre-transform. This is easy. In fact, I'm not sure even we actually really need this, but let's just go ahead and say transform vk surface transform flags, I think. And let's just go with, I guess, identity. Though we could, yeah, we could, actually we need something before this, really. Let me show you what we need. We basically need swap chain extension. Okay. Var next image. Get swap chain images. We're gonna need that later, but yeah, surface capabilities is what we actually need. But yeah, I don't really. Okay, yeah, it's probably instance. Get surface, or how do you even get that? Weird. I mean, you use the physical device for that, but how? That's not what I want. Nope. Okay. Well, we have the device. Maybe that's one. No. Yeah, it's probably surface. Well, it's not. How? Hold on. Oh, Ash window. Maybe Ash window. I don't know. Let's see. Oh, I think I gotta avoid the surface extension, in fact. Yeah, pretty much. Yeah, I gotta avoid that. I forgot. Extensions, KHR, and surface. And no, I don't need to add it as like the device, like the extension name here to the instance extensions, because it's already being added as a required extension for the window, basically. So yeah, what we need here. Come on. Show me what we need. Entry in the instance, okay. Entry in the instance. All right, cool. Now that's the surface extension. Great. Now we could probably get what we want now. So surface extension dot surface capability. Let's go. So you could basically get the capabilities, the formats, the present modes, the supports, and all crazy stuff. But right now, I'm just gonna skip all over that and just gonna take the capabilities only for now. So capabilities, well, surface capabilities is oopsies. Well, is equal to this, and then this, oops, needs the physical device and the surface. Alrighty. There you go. Oopsies. Okay, what else? Surround it and save block. And what's going on the surface? Found. Okay, we only need this. What else? Yeah, that's pretty much it, seems like. Now we could probably get it now. I mean, let's just say pre-transform. It's basically surface capabilities dot current transform. That's what I was talking about. The other one would be this guy. But well, let's just say surface capabilities minimum image count plus 1 for now. What else? sRGB, nonlinear, opaque, true. Yeah, okay. The other one that we need is image extent. Yep. Okay, for the image extent, we're just gonna go with the, I guess, surface capabilities, right? And now here you got a minimum image extent and a maximum image extent and also a current extent. Now you gotta be careful because there's a lot of exceptions here, and you could find them in the registry, like in the Vulkan API spec. So it's basically, what is it called? Yeah, Vulkan creates, well, VK creates Swapchain, Vulkan, and there you go. Creates invoke HR. And there you go. You can get a lot of information from here. And where is that one? Image extent. Actually, I want the VK get physical device surface capabilities. There you go. And it would give you this guy. All right, lovely. So it will be at least one. Okay, there you go. Current extent. Or the special value this. So there is some exceptions to this. You could, just research on this. Well, not research, but just read through this. But for now, at least, I don't want to deal with that. I'm just gonna say current extent because I'm on Windows, so it doesn't really matter honestly for me. But if you are, for example, on Wayland, then you probably want to check this out. But later on, I'm gonna fix this. I'm gonna try to do this right, but right now I'm just I want to do it as fast as possible. But anyways, because we still have a lot to do. In fact, okay. Old swap chain. If you're gonna be recreating the swap chain, there you go. There's also the present mode. I'm just gonna hard code this too to FIFO. So present mode KHR. Oopsies. FIFO. There you go. There's some other present modes. But yeah, clipped surface flags, all swap. What else? There is a lot of crazy stuff here. Surface image usage. Did I do image usage yet? I don't think. Yeah, I'm not. So image usage flags. There you go. And we're gonna use this as a color attachment because we're basically gonna be writing to it from a shader as a color attachment. Okay, but there's some other image usage flag stuff. Other than that, I don't. Yeah, well, there is Q family indices. Q family indices. This is also important. So, std slice from ref. There you go. And because I only have one thing, I don't really need the slice. And we're just gonna go with 0, pretty much, just hard coding this. So yeah, that's as simple as that. Okay, cool. What else? So I think this should hopefully make a swap chain. Let's see if this actually worked out. Where's the other guy? There you go. Let's go with API dump. And let's see if this is right. Okay. Oopsies. Initialization of an object has failed. There you go. Yeah, I probably missed something. So as you can see, create swapchain KHR error initialization failed. Interesting. Well, why? Well, let me check out the validation. I probably have missed something. Let's see. The Vulkan spec states image format and image color space must match the format color space members respectively. One of the vacay surface format KHR struct returned by. Ooh, interesting. Oh, I forgot the A8. There you go. This should work now, hopefully. There you go. Lovely. As simple as that. Now I think we have created the swap chain essentially. And just to even make sure even more, let's go to the API dump. And let's check create, well, there you go, create swapchain KHR, returns vacay success. Lovely. Lovely, okay. Let's go next up. Yeah, next up is pretty much getting the images, the swapchain images. Okay. And to get the swapchain images, you would just say, oopsie, swapchain dot. Actually, not swapchain, yeah. You basically say swapchain extension dot get swapchain images, and then you pass in the swapchain handle. And that's pretty much it. And this is probably in safe, as always. So surround with in safe block. And there you go. Now we got a vector of images, which we should create also a vector of image views from it. And how I'm gonna do that? Well, let's swap chain images. Well, okay, let's see. Let's swap chain image views is equal to in safe, or let's just say, okay, let's say swap chain images, and we're basically going to, yeah, we're gonna map this, I think. We're gonna map this into image views, basically. Right. So essentially, you're gonna get the image, and we need to turn it into an image view. And how are we gonna do that? Well, device dot create swap chain, well, create image view. And then we pass in the image view create info. Oops. Builder. Let's wait for the autocomplete. Okay, let's go. First of all, let's give it the image, which we already have at this point. And yeah, what's next? It probably also needs something else, maybe? Hold on. Create image view. It's, well, it's, first of all, it's in safe. Oh, what happened here? Interesting. None for the allocation callbacks. And we probably have to turn it into an image view and save block. And yeah, there you go, I think. Oh, well, I cannot use this here because I'm in a closure. So let's just use in wrap for now. There's nothing really else that I could do in this case. Expected image view create info found. This is why I don't like actually using closures anymore, like, iterators, stuff, etc. At least for this low level stuff, because of the fact that I can't propagate back the error. I mean, well, I actually can in some sense. Just by returning just by returning a result into there and just making sure that there is no error in the vector. I mean, that's also something that we could do, but honestly, let's not care about that right now. Method defined here, consider borrowing here. Okay, yeah, I gotta borrow here. Oops, there you go. And what's happening with this image, but found a reference to an image. Interesting. I cannot use into iterator because that would mean that it would consume this, guys. But I think it's pretty enough maybe to just dereference it there. It's just a handle. It's nothing crazy there. It's not like the image is like the actual pixels of the image. It's just a handle to an image. So it doesn't matter if you copy it around and stuff. So yeah, otherwise what you could probably also do maybe is to like say copy it or something like that. Maybe? Yeah, copy it. Okay, so you could also do this, copy it, and then you could just, yeah, it just works. Let's go. And of course, this is actually a map iterator right now, not really a vector. So let's turn it into a vector. And we're gonna say collect. You gotta select what you're gonna collect it to. I'm gonna collect it to a vector. And yeah, is it like the CD vec or what? What's happening here? What? Weird. Oh, I didn't have to tell it or what? Weird. Help, consider giving an explicit type. Yeah, I wanted to here, but it didn't let me. There you go. Okay, so that's how you do it. Here you just select like which collection you want. I told it I want a vector, and then here I just said an underscore, meaning that just infer it from the item of this iterator, which is an image view. And there you go, pretty much. Right, now we got the Swapchain image views, lovely. What's next? Let's see. I think right now we could probably start with the event loop, maybe. Let's see. Window event close requested. Let's see what events we have here. Okay, main events cleared. Loop destroyed, redraw events cleared, redraw requested. Now, redraw requested is really interesting when it comes to like GUI applications, which basically sets the control, well, not control flow, but it basically, yeah, I think it's control flow. Hold on. Don't remember exactly. Let's see, hold on. Let's remove this first for a second here. And let's see just one thing. Yeah, there you go. So there's like polling and waiting, and GUI applications likes to wait for new events instead of just keeping on pushing new frames every time. It just wants to basically halt the execution of the whole program until the next event, because pretty much GUI applications doesn't like have visuals every time. Like it only updates itself when there's like an input from the user, and that's why you would use like set wait here and stuff. And then that redraw events would make sense, but it doesn't really make sense here. But just for, I guess, readability, here's what I'm gonna do. Um, I'm gonna use redraw events, redraw requested. Why not? Window ID, I guess. Yeah. But as you would notice, it's not gonna work out. Right. But I'll show you why. I mean, let's try to just print something right now. Hello. And let's see. Just to make sure nothing is going crazy. As you can see, it redraw only once. And it only redraws when something happens, like for example, resizing the window or something like that. Which is of course not what you'd like in a game. You'd like to constantly redraw. So what we could do, we could use main events cleared, I think. Hold on, let me just make sure that is the right event. Yep, exactly. So basically when there's no event, we'd like to try a redraw. So what's happening here? I guess I don't need that, maybe. Yeah, there you go. And now I basically need to say, how do I actually do it? I forgot. Let's see. I guess window request redraw. There you go. So you just tell the window you request from it redraw every time. Otherwise, you could just do the redrawing stuff here. And honestly, coming to think about it, it's much. Let's not add another redirection for no reason, honestly. Let's just work with this one. And this would basically work every frame. Coming to think about it. But of course, if you're making a GUI application which waits instead of polls, then you would want to use redraw requested, but in our case, it's not needed. So, okay, anyway, let's go with this one. So main events cleared, what we gotta do right here. Okay, right. We gotta request the next image from the Swapchain, I think. How are we gonna deal with that? Well, Swapchain extension, the requests, I think. No, not a request. Get Swapchain, acquire. Yeah, acquire next image. And there's also acquire next image too. What's the difference between the two? I don't know. Let's see. Right. Not sure where's the difference between acquire next image info, acquire next image 1 and 2. But it seems like the same thing, huh? Interesting. Or isn't it? Hold on. Let's go back here and let's just go with this guy and let's see the documentation of that too. Oh, I see. So next image 2 takes in, seems like it takes in struct. Interesting. Timeout, semaphore. And what the other one takes again? Swap chain, timeout. It also takes pnext, so that's nice. So you can basically support extensions. Device mask. What is this? Interesting, but we don't need it right now. Let's just go with the one that I know of for now. But I'm interested into using some modern extensions to ease to ease the Vulkan craziness. But anyways, okay. So what's now? Swapchain extension dot acquire next image. Okay, cool. And what we need here, it's not stupidly showing me that guy. Hold on. Let me go to the settings real quick. Let's maybe look for I guess autocomplete or something like that. Code completion. Let's see. Show documentation pop-up in 0, I guess. Would that help? Not really. Let's see out some other one. Show the parameter info pop-up. Let's go. 0 milliseconds. Not sure if I want to show full method signature, but this should help me now. I guess. There you go. Let's go. That's what I like. So I don't have to constantly wait for it. Okay, so timeout U64. Timeout U64. I'm gonna go with, I think, yeah, basically the maximal U64 available. But how do you actually do it again in Rust? I think like this. Yeah, maybe. And then I need the semaphore. I mean, I could just pass in null right now. How do you pass in null? Oh yeah, I think you could basically say maybe null. Yeah, there you go. That's how you do it in Ash. And then vk fence null. We gotta need that later on, but right now I just want to see real quick. This actually works. What's happening right now? News result. Okay. So basically, well, here's the other thing that I don't like about Winit, which is the fact that it's actually using a closure. I mean, that's for a reason. I know that's for a reason and for a good reason, but yeah, it's just annoying. Right now, I can't really propagate my error back into whatever. So yeah, for now, I'm just gonna use WinWrapper. Who cares? So yeah, that's pretty much it, I think. Call to an save function. Cool. All right, so this should give us the index that we need of the next image. Yep, U32, but it also gives us a boolean, interestingly. What is that boolean value? I don't know what that boolean is about. Interesting. Is suboptimal. Oh, okay, interesting. I see. So it's either, yeah, it's next image index and is suboptimal. There you go. Binding is suboptimal is never used. Okay, pretty cool. So basically when it's suboptimal, you basically gotta recreate it for best experience, I guess, or best performance or whatever. But anyway, I'm not gonna handle that now. Next image index. For now, I'm just not gonna make it resizable, I guess. Don't want to deal with that now. Where's the window? There you go. And I could basically use the window builder. New. And then I guess with, I don't know, with resizable. False. If it's not already, actually. It's probably not, but well, let's try to build this. And you gotta give it the event loop. And then of course, if there's an error, propagate it. Oopsies. I've done something crazy. Okay, please don't do this yet. Okay, as you can see, it's actually resizable by default. So let's actually not do that. Let's do dot build, yeah, width resizable, false, and there you go. For now, it's not going to be resizable because to make it resizable, you got to handle some edge cases, which I don't want to deal with now. It's another level. Okay, so what we got to do now? Next image. So now we got the next image. Now we got to basically present it. Now to actually present it properly, we got to need a fence or a semaphore. Okay, let's try to present it and let's see what we're gonna need. Swapchain extension dot present queue present. So you basically use the queues that you got through the device creation to basically send commands to the GPU through Vulkan API. Here it's telling you which queue you're talking about. I think we got the queue already. Yeah, here, there you go. So I could just pass it that queue. We already have one queue which supports everything, graphics, presentation, etc, etc. I don't want to bug you with all the crazy details, but yeah, that should work just fine for now. VK present info, KHR, and then builder. Okay, let's see what we can give it. We gotta give it, I think, a slice of swap chains, right? Yep. And since we have only one swap chain, we're just going to use that little trick, slice from ref. And I'm just going to give it the swap chain. What's next? That's the swap chains. What's next? There's also image indices, like which images do you want to present. We only have one. Next image index. Or honestly, just call it image index, who cares? And yeah, and of course, let's pass in an address here. And there you go. Now expected found results bool. What else we can give this? P image indices. Why it's not completing this? Present info KHR. Oh, I see. Well, no. I don't know why this is not fine. What else? There's results and there's all that crazy stuff. But anyway, let's see. I guess this is the present info. I'm not sure what's going wrong here. Yeah, just gotta give it a queue and that. Add expect in wrap, I guess. No method named. Oh, I see. That was why. Okay, lovely. So I don't really need this anymore. Just pass it directly here. Why not? And yeah, I think that's pretty much it for that one. There is also push next. What is push next? Prepends to give an extension struct. Oh, I see. Results. I don't think I need to do that with semaphores. I may want that. Yeah, I actually need that because basically now when it comes to GPU stuff, like the GPU is so good at doing parallel stuff, and that's basically the default. Like when you send, let's say, two commands or whatever, um, they like, how can I describe it? Basically, in OpenGL, for example, when you do something like render a triangle or whatever, I think if I'm not like if I'm correct, then it would basically just return immediately after it done the job. Basically, I think, or I don't remember exactly what OpenGL was doing. But anyways, in Vulkan, it's like everything is asynchronous. It's like whatever you do, like for example, when I'm gonna say quPresent, or when I'm gonna call quPresent or acquire next image, it would just return right away. I'm not waiting for the acquiring of next image to happen. And I'm also not waiting for the presentation to be done. It's just going to return immediately. I'm just sending that command, but to actually be able to like to tell the GPU or CPU or like the Vulkan API in general here that I want for the presentation to only happen after the acquire next image have finished its job, because in fact, I mean, I cannot really present an image before I even got an image. So to make sure that that is synchronized, we will use semaphores and fences. But generally for GPU and GPU operations, we use semaphores. And then fences, you could use it to like synchronize the CPU with the GPU. For example, let's say you want to wait for the presentation to happen in the CPU here, then you want to proceed, then you would use a fence. But anyways, that's just a little information there, I think. We gotta create a semaphore, and we probably also gonna need a fence too. Yeah, pretty much. So yeah, let's see how we can do that. Okay. So let device, let semaphore. Well, I'm gonna call this. I don't know what to call it. Okay. Well, let's just call it for now fence and semaphore. Pretty much who cares. Later on, I'd want to change the name to something more meaningful, but yeah. So let's do device create semaphore, or yeah, semaphore. And then here, I just gotta give it again, as always, create info, builder dot semaphore is, well, what? What do you even mean there? What does that even mean? No idea. What's that? Semaphore. Weird. I think I don't need anything really. Device, index, stage mask, value. Where this is coming from? Interesting. Yeah, I don't think I need anything there really. So just to build. Well, in fact, instead of build, I gotta do basically a reference. Yeah, that should be fine. Let's go. Oh, yeah, I see now what's happening. So semaphore create info builder. Oops. Oops. Create info, then builder, then do this. And yeah, there is nothing interesting here, at least for now. And let's just make sure to do this and then basically provide the arguments. Oh yeah, allocation callbacks. I forgot about that again. And yeah. Surround it and save block, and let's go. That's pretty much it for that one. Now let's also create a fence because I'm probably gonna need it soon. Maybe, at least for now. Create fence. Okay, device create fence. I just want to show you like hopefully a minimal product where, you know, it's like we just got a Swapchain running, like a Vulkan application running that is just constantly just presenting the images, hopefully, and maybe even clearing the image with some color if we can make that work. I don't know, we'll see. So create fence. Here we need fence create info builder. Okay, how are we gonna deal with that? Yeah, no, we don't need anything here right now. So yeah, that's enough. So now, oh yeah, I also need that. None. Surround and city block. And let's go. That's pretty much it. Now we got a semaphore and a fence. And by the way, until now, I'm really not caring about destroying this stuff. Because it's just not needed to get something working. I don't really care right now. Okay, so okay, let's see. Now here in the semaphore, I'm gonna put the semaphore here. I wonder if I can actually provide a fence here. Maybe I cannot. Call to an unsafe function. Oh, by the way, so like if this is also tells you if it's suboptimal after the presentation or whatever. So yeah. Now this actually gets the present info, okay. Now what this provides me with, does it provide me with fences? I don't think, but just making sure. Yeah, it cannot provide me with a fence. So let's just go with here. Let's just take the fence there, cool. And now what I'm gonna do, wait semaphores, and I'm gonna provide it with one semaphore, slice from ref. And I'm gonna provide it with our semaphore, of course, the reference to our semaphore. Okay, that's something. The other one would be to wait semaphores. Okay. Yeah, I think that's pretty much it. Wait semaphores, image indices, results. You could also use this to like get the result of what happened. But I don't really care right now about that. Yeah, I think that's pretty much it. So here I'm just telling the presentation to wait for this semaphore to signal before actually presenting. And then here I'm telling acquire next image to signal the semaphore when you're done. I'm also telling it to signal this fence. And why? Because I also want to solve or let the CPU wait for at least this acquiring that image to be done, so we do not overload everything. So anyways, so I guess let's try to say fence dot wait or something. Hold on, device wait for fences. Okay, here you tell it fences. Wait all. Like, do you want to wait for all of them or just one of them? Doesn't matter here because we only have one fence. Just give it whatever value. And here, if you want some timeout, I'm just going to go with the maximum value. So basically no timeout. And what else? Do I need something else? No. So what's wrong? Used result. Okay, I see. Dot in wrap for now. And yeah, what's going on here? Oh, it's U64. Sorry. Let's go. Yeah, this should maybe work. Maybe. Uh, yeah, I guess. Let's try this out. Now, as you can see right now, it became black instead of the white that we had before. So I guess it works just fine. So right now, we pretty much got our first little Vulkan example working. We're actually at least doing some work. Where we're basically every frame what we're doing, we're getting the next image from the swap chain, and then basically we're presenting it after we acquired that image, and then we're just waiting for the like to get the actual image, and then we're just proceeding to the next frame. That's basically what's happening right now. If I remove this guy right here, then it would just not wait for the image to even be ready, which is probably not something you want to do. I mean, let me try it out real quick and see just what's gonna happen. Probably will crash or something, or at least will be so slow. Or I mean, it seems fine, but yeah. But yeah. Anyways, let's just keep it like this. And by the way, hold on a second. I have a little idea. That acquire next image too. Does it add something? Does it add the fence? Ooh, well, no, I'm not talking about this one. No, that's not what I wanted. Yeah, Q present. Hold on. It's like, is there a better version of Q present? No, it doesn't seem to be. I mean, at least not in the Swapchain extension itself. So yeah, anyways. So that's pretty much it for that one. Next up, hopefully what I'd like to try out is maybe like color the images before they get presented. Uh, and for that, we could go the crazy route, which is creating a pipeline, shaders, and crazy stuff like that. But I mean, if we do that, then let's just create a triangle. Let's just draw a triangle. So I think we're gonna go a little bit on a little bit easier route. Hopefully we can succeed in that because not a lot of people actually do this. But basically, well, first of all, I need to create like a command pool and then a command buffer. Then we're basically going to use that to essentially, yeah, to color we're just going to use a color image command basically instead of using the pipeline. I think let's try that out. I mean, yeah. And of course, for that, we gotta first of all need a command pool. So, okay, device, create command pool. Here we gotta give it the command pool rate info. Builder. Okay, key family index. So here, just gotta hard code it 0. Oh, what else? Yeah, that seems like pretty much it. Yep. And of course, just gonna do this and Alt Shift Enter. Alt Shift Enter. Okay, why that doesn't work? No idea. Anyways, route and save block. Let's go. Okay, so that's pretty much it for the command pool. Now let's create one command buffer. And here we don't actually create it. We actually allocate it from the command pool. I'll know. Allocate command buffers, and here you give it the allocate the command buffer allocate info. Well, of course, reference to make a command pool. There you go. What's next? There's the command buffer count, I think. It's just going to be one command buffer, and then the level, which is going to be command buffer level primary. There you go. There you go. So run save block. And yeah, so we got right now a vacay result of vector command buffers. Cool. And we're pretty much just gonna get the first guy into iter. I don't need the vector. I'm just gonna consume it, and then next, and basically context, no command buffer, in wrap. No, right. Do this, and there you go. So we got a command buffer now. Lovely. Unless, of course, if I missed something, but yeah, that seems fine. Now that we got a command for a command buffer, I think we're ready. So basically, so alrighty, where we were here. Yeah, before we actually present, let's do the thing that we want to do. So device, I think dot start command buffer or something like that. Begin, yeah, begin command buffer. Give it the command buffer, then command buffer begin info. Builder. And then let's see what we need here. Doesn't seem like we need anything really. At least not for now. Yeah. Yeah, I think this is in safe again. And use results. So it also gives us a result. What? Interesting. So just unwrap this. And it doesn't seem like it's in safe for some reason. Okay. So yeah, that's pretty much it. And next step, of course, we gotta also make sure to like end the command buffer after you're done with it. And this also gives us a result, which we can wrap. And between the two, well, is this in safe? Oh, it needs some argument, which is the command buffer pretty much. Yeah, that's pretty much it. Now, between these two, what we gotta do, we gotta, tell it which commands we want to send to the GPU. So let's see what command we want here. Think clear image. Yeah, cmd clear color image. This is the command that I'm gonna try to use here. So we gotta give it the command buffer. We gotta give it the image, which is, and by the way, this cmd clear color image requires another image usage, not color attachment. This is for shaders, which we didn't do yet, but we're gonna do eventually. But for now, what we really need is, well, transfer DST, I think. Yeah, because it's gonna be a transfer destination. Because this is actually not a graphics command. This is a transfer command, unless if I'm mistaken. So yeah, but we'll see. Other than that, we got the image. All right, image, interesting. So yeah, we could easily take that. Well, we have the Swapchain images here, as you can see. So you could just simply say Swapchain images and give it the image index. And then we can basically take the image. Here, the image layout. Well, I'm not really exactly sure about this one, but it should hopefully be transfer DST opt optimal, I think. Maybe not. Maybe we gotta actually use a, what is it called? A barrier to like switch the image layout to maybe just indefine, but we'll see. The other one is clear color value. Now this basically is a union, I think, if I remember well. It changes depending on the format of the image. Now we already have hard-coded the image format, so this should be simple. We had hard format. We used sRGB BGRA8 non-linear. So we gotta use a floating clear color. I don't remember exactly how this actually works. It was kind of tricky. I remember. Let's see if I can figure it out again. Clear color value. Okay, let's try that out. Clear color value. Yeah, as you can see, there's like float 32. It's a union. Float 32, yin 32, un 32. We're gonna use float 32. And yeah, I think what's happening right now. There you go. Expected identifier found dot. Huh. Can I just do this? Maybe? Expected found workplace with the column like this. Yeah, expected F32 for array. I don't know, let's just try something here. See how that goes. Invalid suffix for float literal. P1 of F32, okay. Is that it? Yeah, I guess we have done that one. I mean, it seems fine. So let's see the next one. It's image sub-resource range. It's a slice, but we only need one. So from ref here, we're gonna go with the reference to an image sub-resource range. Builder. Okay. So the aspect mask. Let's see. What's that? It's a color or none. Interesting. I guess color. Not sure about that. Okay, what's next? Base array layer. I think 0. So we could probably just leave that as it is. Maybe. But what's important here is the layer count. It's gonna be 1, and then also the level count, which is also gonna be 1, I think. If I'm not mistaken. There you go. What's happening here? Cannot be indexed by U32. Interesting. Can I say as usize? There you go. Lovely. And that's pretty much it. Okay, seems great. Lovely. Now we have constructed hopefully the command buffer. What's next? It's gonna be actually submitting the command buffer to the GPU through the queue to actually execute it. Okay, device will submit, queue submit, and you gotta give it the queue, which you already have. You gotta give it the submits, which is gonna be only one. Hopefully this would work. Command buffer, command buffer count. Okay. So yeah, we could provide it with a semaphore. Interesting. Interesting. So we're probably gonna need 2 semaphores at this point. Yeah. Well, first of all, I'm gonna tell this guy to actually wait for the next image semaphore. So cd again, slice from ref. Okay. Semaphore. Lovely. Okay, what else? That submits, and also we could provide the offense. Interesting. So let's actually not provide a dispense anymore. Let's just say, well, vacate fence, right? No. And yeah, and we gotta provide it here instead. Yeah, here. I think. And use result. Okay, cool. We're gonna need, of course, more stuff. Well, I'm gonna create another semaphore. What? Okay, let's actually add a none here. Okay, looking great. Apparently we don't use Swapchain image views. Oh, why? Why? Yeah, we're gonna actually need that in the shader stuff, not really. Yeah, we're not using that yet. Okay. What I wanted. Yeah, I wanted to create a second semaphore. So let's semaphore 2. Well, basically same exact thing. Nothing crazy there. And yeah, so semaphore. And this one actually will wait for the semaphore 2 instead of the semaphore 1. We don't want it right now. We don't want to present after we got an image. We actually want to present after we have finished our operation here, which is actually coloring the image. And of course, the coloring the image actually waits for the image to exist first of. So yeah, that's basically how it goes. So this would wait for semaphore 2. Nice. Okay. From ref, semaphore. And by the way, I almost forgot one thing. After you use the fence one time, after you waited for it one time, you can also reset it after, or reset it after that. So reset fences, and then cd slice from ref. Fence. What's going on here? I guess in Raptors. Yep, there you go. So after waiting for the fence, basically after using it, you gotta reset it. That's one thing. The other thing is that. So yeah, queue submit. We're waiting for the semaphore, and we're gonna signal a one semaphore. Which is semaphore 2. That this guy is waiting on after we're done with our operation. Okay, what else I could give? I guess the command buffer count. Is it? Yeah. Well, command buffers. There you go. Here from ref, command buffer. Like which command buffers basically you want to actually submit to the queue. We basically have one command buffer right there. There you go. Other than that, I don't think I need anything else. Yeah, I don't think. Wait, stem buffers, command buffers. Yeah, that's pretty much it, really. Lovely. Does this actually, by the way, even though this is in safe, it's not really telling me anything about that. Interesting. Weird. Anyways, so I think that's, oh, because it's made this unsafe. Interesting. Well, I don't exactly want that, but anyways. So let's see if this would even work out. Probably a lot of errors right there. Ooh, okay. I mean, it seems to be working out, and it's in fact white, which is correct. It is the color that I actually gave right here. Okay, cool. Now, let's see if it will be yellow. If that's the case, then we're successful. Yellow? There you go. Okay, so we got a yellow window. Let's go. Nice. Amazing. Why it's still resizable, by the way? Of course, as you can see, it actually crashes when it becomes resizable. Like when you resize it, which is correct because we're not handling that yet. With resizable equal to false. I mean, I'm setting it to be not be resizable. So what the? No idea. Really, no idea. It's weird. I'm telling it to not be resizable, but it is resizable. But anyways. Okay. So that's pretty much it for that one. Right now, we actually have done it. Pretty much, we have created the most minimal, well, the most minimal graphical Vulkan application, basically, which basically just, you know, displays, like colored images on the window, essentially. It took us only 176 lines of code. So that is very amazing. Now, to top it all off, let's make a little animation here, I think. Okay. So that animation would basically be, let's set this to one variable. Let's call it C because I run out of names. And let's just say if 32 C, well, C is equal to, well, if 32 maybe sign. Okay, and by the way, let C is equal to F2 sign off time. Now I don't remember how do you get the time in Rust. I guess it's std instant or something like that. I have no idea. Yeah, let's check it out. Rust instant std time. Yeah, my bad. That's okay. And what we have here, we have Unix epoch, an anchoring time which can be used to create since Unix epoch. No, let's just go with duration. I think I'm not sure which one is best in our case, but let's just go with now. This is what I know. Return instance corresponding to now. And yeah, I guess as seconds or elapsed, maybe. Yeah, as seconds if 32 I think, yeah, maybe. Can we say F64 here? We can. No, no, we can't. There you go. Oh, I see. So we could probably say this and then essentially say sign. And there you go. Lovely. So we just got the instant now collapsed as seconds F32, and we got the sign of that. And which means it would be a value from -1 to 1.0, which is not what we want. We want it to be from 0 to 1.0. So what we're gonna do, and just to show you what I mean, and by the way, we have done that in 2 hours and 30 minutes. I mean, you could probably just shave off that 30 minutes. We probably have done it only in 2 hours, because that first 30 minute was just spent dealing with that stupid change in raw window handle thing. We didn't even really figure it out. We have just changed to another version. But anyway, pretty much we got it working in 2 hours, which is lovely. It's crazy. So yeah, okay. Sine of x. So as you can see, sine gives us a value from -1 to 1. Now basically a color here, you gotta be from 0 to 1. So what we're gonna do, first of all, the height of this function, or the magnitude of this function, is 2. You know, it's say this is 2, not 1. So first of all, I'm going to scale it down to 0.5, basically half the size or half the height or magnitude, whichever you want to call it. But as you can see, it's still from -0.5 to 0.5 instead of from 0 to 1. Well, I could just, take it up 0.5 times. So plus 0.5, and there you go. Right now it's from 0 to 1. There you go. That's what I got to do. Just times 0.5 plus 0.5. As simple as that. So yeah, times 0.5 plus 0.5, and this should give us a little color right there between 0 and 1. Let's see how that would go. Maybe too slow. Let's see. And by the way, let me remove the debug because it's slowing everything down too. So let's just say this. There you go, much faster, much more responsive. Okay, so I think it's probably just too slow. The frequency, basically. So let's try to change the frequency, I guess, and see what happens. Interesting. Okay, let's try to go even more further. Really? Oh, my bad. My bad. I'm actually changing the magnitude here. No, it's not what I meant. Yep, that's not what I meant. I want to change the frequency, which I should by basically changing the S, which is this guy here. So let's do times, I don't want to say 100, let's see what's going to happen there. Not enough, I think. Let's go to a higher value. What? Weird. I mean, I'm kind of starting to see something, maybe. Yeah, I can definitely something going on. I2K. Let's see. Kinda? Something's wrong there. Actually, let's just print line. See. Interestingly, it stays quite a bit in 0.9 for some reason. Hold on a second. Well, instead of as seconds, what about as millis, for example? The F30, but I cannot make it F32 or what? Yeah, oh, it gives me U128. Interesting. Well. As F32 maybe? Yeah, why it's not printing anything now? Oh, there you go. It's actually just printing 0.5. Crazy. I think maybe I know what's happening here. Oh, let's say that this is now. And let's just maybe say now here. Maybe I know what's happening here. Okay. So now minus, well, sorry, that as millis, well, as millis. Let's just, what elapsed gives me duration. No, not minus now. Then the elapsed, I guess. Hold on. What's happening here? Oh, it already gives me the duration. Nice. And then I could basically say as seconds. And then sine times 0.5 plus 0.5. Let's see if this would work out as expected. There you go. Okay, there you go. That's what I'm talking about. Lovely. So it's working out just great. Let's go. We got an animation right now. So apparently just my time calculations was right. Or at least not my usage of the API. Anyways, so that's pretty much it. Lovely. Otherwise, we could make this red. And in fact, we don't even need to tell it exactly there. Okay. Now it would be red. Animating red. There you go. Nice. Okay, so we have made it. Nice. Lovely. So next up would basically be actually creating a triangle in Vulkan. And that would need some other more crazy steps. Well, I wonder if we really have the time for this at this point. But pretty much I'm just gonna take a little break and come back. See you then.